So this is problem 18-4, and so this talks about break-even analysis and target income. So in this problem we have Astro Company says they sold 20,000 units of its product and incurred a $50,000 loss ignoring taxes. So that happened in 2015. So for the next year, 2016, the production manager decides that, hey, if we buy this certain machine, we can reduce our looks like we can reduce our variable cost by 50%. However, it's going to increase our fixed cost by 20%. And then it also says, kind of as a side note, that the max capacity of this new machine will be 40,000 units per year. And so we had to figure out, hey, is this a good deal or not? Do we do this? Do we spend this extra money to get this machine, or do we not? So what we're going to be doing here, by spending money and increasing our fixed costs and reducing our variable costs, we're actually increasing our risk, but we're also increasing our leverage. And so that means that, hey, if we don't sell very many units, that's not going to be good, because those fixed costs are guaranteed. However, if we're able to sell a lot of units, we're reducing our fixed costs. That means we're going to benefit if we sell a lot of units and benefit a lot more. So let's go ahead and walk through this analysis. So the first thing it's asked us to do is compute a break-even point in sales dollars for 2015, so the year that already happened. And so to do that, to do the break-even in sales dollars, we just take our fixed cost and divide it by our contribution margin ratio. So it gives us our fixed cost for 2015. That's 250,000. And then for the contribution margin ratio, so that's going to be our variable cost, our sales minus our variable cost gives us our contribution margin. Divide that by the sales gives us the contribution margin ratio. And for this problem and for the rest of the stuff that we're going to be doing down here, it's going to be easy if we think about that as a per unit basis. You don't have to do it on a per unit. You could do it in total, but let's just talk about it on a per unit basis, and it'll make sense as we talk about the other parts of this problem. So our contribution margin ratio is, we know, let me just write that over here. That's going to be sales minus our variable cost divided by our sales. So let's talk about it on a per unit basis. So sales per unit is going to be $1 million in sales divided by 20,000 units sold. And we want to subtract out variable cost per unit. So the variable cost per unit is 800,000 divided by 20,000. 20,000. And we want to divide that by our sales per unit. So that gives us a break-even, contribution margin ratio of 20%. Now, there's a lot of numbers going on here, so I'm just going to reduce this down just so we can talk about, so we know what numbers we're talking about. So our sales per unit, so 1 million divided by 20,000, that equals 50. $800,000 in variable cost minus or divided by 20,000 is 40. And our sales we just calculated is at 50. So a little bit simpler to visually see what's going on there. So to get our break even in sales dollars, we just divide these two. So that means that we have to have $1.25 million in total sales in order to break even. And so, hey, that makes sense. We had $1 million in sales in 2015 and we had a loss. So we actually have to have 1.250 in order to just to break even, just come out right at 0. Okay, so in part 2, we have our projections. So in 2016, it hasn't happened yet, but we're just we're going to change a scenario where we're going to get the new machine, and let's do a break-even analysis for it. So we want to compute the predicted break-even point in sales dollars for 2016, assuming the machine is installed, but there's no change in the unit selling price. Okay, so our variable cost, originally we have $215,000, but we're going to incur an extra $200,000 if we go this route and get the new machine. So we're going to have variable costs of $450,000 instead of $250,000. Now this is also going to change our contribution margin ratio. Our sales are going to remain the same, but our variable cost, it says, is we're going to cut it in half. It's going to be 50% of what it was. So originally it was 40, now it's going to be 20. So now that increases our contribution margin up to 60%. So that is a good deal. Let's see if that helps us out here. So now our break even in sales dollars is $750,000. So, based on this scenario, if we can do 20,000 units, so we're not gonna have a drop off. Hey, it's a much better deal to go ahead and reduce our variable cost by 50% by spending this extra $200,000 a year. That means that we only have to sell $750,000 to make a profit. So all things remaining equal, if we would have had the same sales in 2015 as we're predicting for 16, we would have been better off going ahead and spending that money. So part 3 says prepare a forecasted contribution margin income statement for 2016 that shows the expected results with the machine installed, assuming that the unit selling price and the number of units sold will not change, and don't worry about taxes. So okay, so we're going to assume the same amount of sales, so that's 20,000. Our sales price per unit is not going to change, it's still going to stay at 50. Our variable cost, so that went from 40 down to 20, and our fixed cost, it's actually not fixed cost per unit, sorry, that's just fixed cost. In total, that's going to be that 450,000. So calculate our sales. If we do our units times the sales per unit is 1,000,000. Hey, that makes sense. That's what we got up here. Now our variable cost, units times our per unit variable cost. Whoops. Times variable cost. That's the 20. So now we have 400,000 of variable cost. Okay, that makes sense because it was 800,000. We reduced it by 50%, so we have 400,000, and our fixed costs have gone up to 450, which means, hey, if we go ahead and we get this new machine, we'll actually have $150,000 in net income instead of a loss of 50, so a $200,000 turnaround. Okay, so part 4. So it says compute the sales required in both dollars and units to earn $200,000 of target pre-tax income in 2016 with the machine installed. All right, so our target profit, we want to have a net income of $200,000. And so the only difference between our target profit formula and our break-even formula is within fixed cost, we just do the exact same formula, but we add the target profit to it. So really simple, really straightforward. So now our our fixed cost plus target profit. So we have our 450,000 plus our target profit. So now our required sales, fixed cost plus target, is 650. And we already calculated our contribution margin of 60%. Then we just divide. So that means if we want to break even plus earn our target profit, we would have to sell 1,083,333 units. Sorry, that's it in dollars. So now in the second part, we want to do ahead and do that in units. And so the only change in our formula here, instead of using the contribution margin ratio, we want to use the contribution margin per unit to give us a result that's in units. So our numerator is the exact same, so we can just grab that right here. And now we just divide that by our contribution margin per unit, which we calculated that at our 50 minus 30. Oops. Sorry. So sales minus variable cost, and let's just get that in our the right format. There we go. So that our contribution margin per unit is 30 divided by our fixed cost plus our target. That means we need to sell 21,667 in order to break even plus earn our target profit. All right, and the last part, number 5. So it says prepare a forecasted contribution margin income statement that shows the results at the sales level computed in part 4. Assume no taxes will be due. All right. So we want to assume the units from part 4 appear. It's right here. And then our sales in dollars per unit, we calculate that at 50. Our variable cost was 20, and the fixed cost is 450. All right, so our sales is units times price per unit. Our variable cost is units times variable cost per unit. And then fixed cost equals our 450 right here. So perfect, comes out to be just like we calculated before. So break even in units, that matches here. Our target profit was 200,000. That's our target profit up here. And as far as Connect goes, it may give you a little bit of it may want to accept a number that's rounded. For example, like this, this is not a even number. So if that's the case, and it wants to use just like the whole number, which I think it might say something about whole numbers up here. No. Oh, round to the whole numbers. If it's giving you trouble, if it's a rounding error, what you can do up here is just put in a round function. And so 0 means no decimals. And so it looks the same, except what we've done now is now we don't have any decimals. And it actually changes this. Will actually be 200,000 and $10. So whatever Connect wants you to do on that one.